A small block of mass 100 gram moves with uniform speed in a horizontal circular groove with vertical sidewalls of radius 25 centimeters. If the block takes 2 seconds to complete one round, find the normal contact by the sidewall of groove. So here we have to find out normal contact force, and that is equal to MA. So for that purpose, we need centripetal acceleration because path is circular. So in this direction, there will be centripetal acceleration that will be V square upon R. And at this point, we have to find out normal contact force, and that would be MA. So here, distance covered in one round divided by time taken will give velocity. So velocity will be equal to 2 pi r divided by time. So 2 into pi into radius 0.25 divided by time taken is 2. So this will be equal to, if we put the value of pi as 3.14 and we evaluate it, so it will come out to be 0.785 meter per second. Now centripetal acceleration is given by V square upon R. So V square means 0.785 whole square divided by radius is 0.25. So on simplification, we will get 2.5 meter per second square. So normal contact force would be M times AC. So that is mass is 100 gram. So 0.1 kg into AC is 2.5. So this will become 0.25 Newton. Now, next question is, the road at a circular turn of radius 20 meter is banked by an angle of 10 degree. With what speed should a vehicle move on the turn so that the normal contact force is able to provide the necessary centripetal force? So here situation is like this. This is angle theta, which is given as 10 degree. And the condition is that normal contact force should be able to provide necessary centripetal force. So condition will be equal to V square equal to RG times tan theta. Derivations of this formula we will study later on. So here our concern is to find the speed. So V will be equal to root of RG tan theta. So we can put the values. The radius is 10, G is 9.8 times tan 10 degree. It is given that 10 degree is 0.18. So we put this value here. 10 into 9.8 into 0.18. So on evaluation, it will be 4.2 meter per second. Next question. A body weighs 98 Newton on a spring balance at North Pole. So W is given by mg. So 98 equal to m times 10 from where? Let's take it as m will be equal to 9.8 Newton, but it is better to take the value of G as 9.8 here because it is mentioned. So 9.8. So M will give 10 kg. Now, the question says, what will be the reading on the same scale if it is shifted to equator? So weight at equator is given by W dash equal to W minus mr omega square, where omega is angular speed and r is the radius of Earth. So we can say the true value mg 98 found at pole minus mr. So mass we have found as 10 kg. The radius of Earth is 6400 into 10 to the power 3 meter into omega. Omega is angular speed of Earth. So 2 pi by t is equal to omega. So omega square will be equal to 4 pi square divided by t square. And time period for Earth is 24 hours. So 24 into 3600. So we put this value here. So we can say this value will become 4 pi square, 4 pi square divided by 24 into 3600 square. Now, if we simplify this all, so we will get 98 minus 0.34, which will be equal to 97.66 Newton. Now, let's study the worked out problems. Question number 1. A car has to move on a level turn of radius 45 meter. R is given as 45 meter. If the coefficient of static friction between the tire and the road is 2, here mu s is given as 2. Find the maximum speed the car can take without skidding. The condition is friction must be equal to centripetal force. Fr must be equal to mv square upon r, or mu mg is equal to mv square upon r. Mm will consider out. Our concern is to find v equal to root of mu r g. So let's evaluate it. Mu r g. Mu is 2. Radius is given as 45 and g is taken as 10. So this will be root 900, which is 30 meters per second. Let's take next question. A circular track of radius 600 meters, r is 600 meters, is to be designed for cars at an average speed of v is given as 180 kilometer per hour, which means 180 into 5 by 18 meter per second, which will be 50 meter per second. Now, question is, what should be the angle of banking of the track? The necessary condition is v square equal to rg tan theta, or v equal to root rg tan theta. We can put the values. So here our concern is to find theta. So we should write tan theta equal to v square upon rg. So theta equal to tan inverse v square upon rg. Now let's evaluate it. So tan inverse v square, that is 2500 divided by r is 600 into g is 10. So this will become 5 5 5 12. So tan inverse 5 by 12. Now, if we use calculator, we will get theta equal to 22.6 degree, which is our answer. Thank you for watching.